Hi, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 16. Today, our group will present about development of temperature-based weather forecasting model by using neural fuzzy system. So, this is our group members. For the background, this study focuses on advancing weather forecasting, particularly in temperature prediction, using computer-based models such as artificial neural networks and fuzzy logic. The aim is to create accurate forecasting model applicable across diverse regions for critical sectors like flight, agriculture, and tourism. The research explores innovative techniques, including genetic algorithm and adaptable fuzzy neural network, to enhance the understanding of meteorological variables. The current neural network model proficiently analyzes radiation temperature, revealing global temperature trends over the last 140 years and exposing patterns that may have gone unnoticed. Despite the time-consuming nature of detailed rules and functions, fuzzy systems prove valuable for decision-making in unpredictable temperature prediction. This adaptability is showcased across various fields, emphasizing the significance of considering all influencing factors in climate for effective temperature forecasting over the next century.
Next is methodology of application. The first method that has been used is fuzzy rule-based neural network. Input layer, the original ambiguous variable are sent to this layer without any fuzziness or extra complexity. Stated differently, the input layer of the neural fuzzy inference system is in charge of receiving the first exact input value and transferring them to the later layers for additional processing. After that, the temperature data, which is now completely fuzzy, is sent to other layer of the neural fuzzy inference system for additional processing. This first layer is fundamental to influencing the subsequent fuzzy logic-based inference process and is essential for capturing the specific environmental elements that impact weather patterns. Okay, next is the fuzzification layer. These original variable values are translated into fuzzy representation by means of this layer. In this layer, every node is associated with a distinct fuzzy set such as lower, lower slightly, and moderate in that order. In order to capture the most pertinent fuzzy representation of the temperature data, the layer then chooses the fuzzy set with the greatest membership value. The value linked to the highest membership degree is then chosen by the layer. The neural training layer then applies the selected value in accordance with the maximum membership degree concept. To put in other way, this layer aids in the fuzzy interpretation of the original input, and then the neural network training process use the most pertinent fuzzy representation for additional processing. Okay, the next one is neural training layer. This layer applies with the popular BP algorithm, and this is straightforward neural network with an input and one output. The input, hidden, and output layer of the neural network are the fundamental component of the backpropagation artificial neural network, which is BPANN. It also trains itself by collecting inputs from the previous layer and sending output to the one after it using the BP approach. These Y are set by BP algorithm during the data training process. The Y are the Y are then updated using the minimum error between the real and forecast value. When it comes to temperature-based weather forecasting, the BPAN ANN can discover intricate patterns and convert and connection in the data, which evaluate helps which eventually helps it provide forecasts that are more accurate. Okay, next is the output layer. In weather forecasting, particularly in the context of temperature prediction using the neural fuzzy inference system, the layer responsible for generating a fuzzy number output aligns with the traditional output layer of artificial neural networks. This layer, analogs to ANN output layer, produce a fuzzy numbers as the result of the model inference process.
For the next methodology of application, we use Morandi-Bostani 2015. Based on the flowchart, the process begins with the identification of a problem or task related to temperature forecasting. The data used for this task is obtained from the meteorological organization adapted province, reflecting the information received from that source. Okay, and then they will separate into library studies and data collection. Um, the library studies is to comprehend the complex subject of temperature forecasting and to study existing methodologies in the field. Extensive research is conducted on relevant literature. For the data collection, the temperature forecast data is gathered from the meteorological organization adapted province. This data become crucial component for training and evaluating the model. Next, after library studies and data collection, we will go to normalization of choice, which consists of data pre-processing. The first step of the algorithm is to prepare the real temperature forecasting data for model through a series of measures. This include normalization in ensuring the data is in standardized format suitable for the subsequent stage of the algorithm. Normalization involves scaling the data to a standard range contributing to the model robustness and accuracy. Next, the design and implementation of neural fuzzy network algorithm, which consists neural fuzzy network. The second phase of algorithm involve the design and implementation of neural fuzzy network. This hybrid model combine neural network classifiers with fuzzy logic to handle the uncertainty inherent in temperature forecast data. The design takes into account of account the characteristic of the data from previous season, optimizing the network for effective learning. Next, for the genetic algorithm implemented on neural fuzzy network, genetic network processing. The third phase focuses on applying genetic algorithm to optimize the result obtained from the neural fuzzy network. Genetic algorithm work on involving the parameter and structure of the neural fuzzy network based on performance achieved. This stage aims to minimize error in the temperature forecasting, enhancing the model's accuracy. Next, analysis and conclusion. The overall algorithm is structured in three phases, which pre-processing, neural fuzzy network processing, and genetic network processing. Each phase contribute to the model's ability to make accurate temperature forecast. The normalization process is be treated at different stages, ensuring that the data remain appropriately scaled and standardized throughout the algorithm. Conclusions are drawn based on the analysis of the model performance in predicting temperature forecasts.
Okay, the third method is architecture of the radial basis function neural network. In this slide, there are shows a figure about RBFNN model. RBFNN model has three layers, which are input layer, hidden layer, and output layer. So in input layer, this is where the data comes in. Each node in this layer represents one feature of the data. For a temperature-based weather forecasting model, the input layer will receive historical temperature data along with other relevant weather parameters such as humidity, pressure, wind speed, and so on. Each node in this layer will represent one type of weather measure. Okay, the next layer is hidden layer. This is the middle part and is the some complex math to process the data from the input layer. Each node here is a neuron that has a function that measures how close the input data to a certain point. The width of this function determines how much of the input data around the setted around the center they consider. In the context of weather forecasting, the neuron in the hidden layer will process the input data by comparing it to a typical weather patterns. For example, one neuron might be turned to recognize patterns that lead to a cold front, while another might recognize pattern indicating a heat wave. The weight of the neurons will determine how sensitive each neuron is to variation in weather patterns. A wider neuron might respond to a broader range of temperature, while a narrow one might only respond to a specific temperature range. Okay, the last layer is output layer. This part combines the result from the hidden layer and produce the final output, which could be a prediction or classification. The sigma symbol represents summing up all the contribution from the hidden neurons with by the factors W0, W1 until Wn to produce the output Q1, Q2 until Qp. The output layer will combine the process data to predict future temperature. It might predict whether the temperature rise, fall, or remain stable. The weights will determine how much influence each pattern recognized by the hidden layer has on the final forecast.
Okay, this is the benefit of neural fuzzy system to weather forecasting. Okay, the first benefit is improved currency. Second one is relatively stable performance.
Okay, the third benefit is pattern recognition. Next, adaptability. And lastly, his handling uncertainty.